Alright, so to begin, we will start dealing with the interaction with our puzzle. Since we want to be able to click on each individual meshes, we're going to need to create a on-click event for each. Now, I'm lazy, I don't want to create the script more than once, so we are just going to use some loops here to bind the events, basically. So let's get our tiles list, our meshes list, whatever I'm calling it. We'll do a for each here. For each loop on begin play, and from here we are going to bind an event. So we'll take our reference here and we'll say bind event to on click. Bind event on clicked, and from there we just need to give it an event. So we'll say custom event, add custom event, and we'll say mesh clicked. Alright, so now what this does is it loops through all of our meshes, and when any of them are touched, well, it creates an event that when any of them are touched, or clicked on rather, it will fire this mesh clicked event. You could do the same thing with just getting a reference to each individual mesh and doing it over and over and over again, but it's easier to do through a loop. Alright, so on mesh clicked, we want to get our touched component. This is a reference to our mesh that we touched. We're going to promote that to a variable, and we'll call this clicked mesh. Let's fix that. Alright, so now we have a saved reference to the mesh that we clicked. When this event fires, it breaks the binding to the click event on the mesh, so we're going to have to reset that. So we're going to take our mesh here and we're going to do the same thing that we did above, and we're just going to reset it. So click on bind event on clicked, and we're just going to wire that right back into the same event. Alright, so this will just enable us to click on something and then be able to click on it again. Let's do a little test here, so we'll do a print string. And we're just going to print the name of the mesh that we clicked on. Okay, it's display name and print it. So we'll hit compile and we'll hit play because this has to be during gameplay. Alright, so we got, alright, so we're getting all the different cubes here. You can tell by the number on the top left there. It's being shown. Alright, so that's nothing exciting, it's just telling us what we clicked on. So let's do something more exciting. We need to be able to get the neighbors of the one that we clicked on. So what we're going to do is we're going to take our click tile. Actually, we're going to get a function first, and we'll make this get neighbors. Get neighbors. And all this one is going to do is we're going to do an overlap and see what collision boxes that we actually hit with our overlap. So we're going to do a sphere overlap components. Sphere overlap components, because we're going to be looking for any of those spaces that we created earlier, the spaces boxes. This is why we made them smaller than the actual meshes themselves. If you imagine our grid here, and say we have our box here, and we want to get its neighbors, we're going to do a sphere, which is circular. So it will only hit the boxes here, 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 and here. The top, left, bottom, and right. It won't hit these corner boxes because it only cuts the corner of the mesh, it doesn't actually hit the center. So that's what we're going to be working with here. That's why we're using a sphere. Alright, so our sphere position is going to be at the well, it wants to be the center of the one that we clicked on. So we're going to need to get our clicked mesh. We have a variable out here, so let's just use that. From there, we'll just need to get the world location. And plug that in. We need to give it a sphere radius. So we're going to use a sphere radius based on our mesh size. So we'll just get our mesh size, drag it in. And object types, we just need to be able to interact with the other types of components. So just to keep things simple, I'm just going to make an array. Make array. And most of our components should be either static or dynamic, so we'll just use both. And then we're going to filter. Should be box collision or box component, box collision. Box component for some reason. Okay, yeah, I guess it's just a box component then in this version. From there, we just need to output basically our list of neighbors. So we'll do a return node, and we'll give it a output parameter, and we'll call this neighbors. Neighbors, and we're going to make this of type primitive component. And we also need to make it an array. There we go. Alright, we'll hit compile on that, and let's go back to our event graph. So on click, we will get our neighbors. And just for testing purposes, we'll run for each again. And a print string. We'll just get all of the indexes, I guess. And that should tell us how many neighbors our one that we clicked on has. So let's click the center one. That is getting way too many neighbors. Alright, so it wasn't screwing up at all. I was just being dumb. I had our grid size set to 5 and I didn't realize it. So if I hit play and then I click on the center one, it's actually only getting out that the 5. So the one in the center that I clicked on, left, the right, top, and bottom. Alright, so for the next section, we actually need to do something with that list of neighbors that we created. So let's create another function, and we'll do something with that information. We're going to take all of the neighbors and figure out which one we want to move to. So we'll just call this getMoveTo. Alright, and for that we need an input parameter so we can give in the neighbors. We'll call this neighbors list. Alright. So since we're going to be getting a move to target, our move to target will be a instance of one of the spaces that we created, one of the box collisions, and it's only going to be a singular one. So let's create a new variable and we'll track that. We'll call this move to target, and primitive component singular variable. We're good to go there. So the first thing we need to do is we want to clear this variable. Just in case, from old iterations or whatever, that it's still set. The next thing we want to do is we want to affect the neighbors list here, so we're going to use a for each loop. Connect that in. Alright, so for each of these, the target we want to move to in a slide puzzle is always the empty space. So we need to determine which of these neighbors is an empty space. So for that, we're going to see if any of these boxes here overlap any other part of this puzzle actor. So if it were to overlap a mesh, for instance, then we would know that it's occupied and not an empty space. So we want to get the say overlapping actor is overlapping actor, and for the other pin we'll just say self. So if this box is overlapping any other part of this actor, we want to know about it. We'll use branch, and since we want to get the empty space, we'll use the false, as in it's not overlapping any other part, and from there we just want to set our move to target. So if false, we'll set our move to target to our array element. Alright, and that gives us our destination to move to. Alright, and when we're completed, we just want to return. It's a return node. Alright, let's add that into the growing list here. Get move to. add that in. Now it is entirely possible that you click on an actor that's completely surrounded and doesn't have an empty space next to it. So we need to make sure that we think of that case. And we don't want to actually call move to if we don't have anywhere to move to. You know, it's directly adjacent. So we're going to get our move to target, and we need to check if it's valid. So we'll do an is valid, connect up the execution pin. As you remember, in our get move to, we cleared that value here. So if it never gets set through our loop, then it should still be invalid. Alright, so if it is valid, we want to start moving it, right? So we're going to need a custom event. Add a custom event, we'll just call this move to. And if it is valid, we will call move to. It's that simple. Alright, that basically sums it up for this section. We get the clicked actor, we reset the binding. From there we get the clicked actor's neighbors, and we take that neighbors list and decide which one is empty, if any, and we set our move to target. Then we need to make sure that we have an empty target, and from there we decide, yep, we do. Let's move to the next actor. And in the next section we'll be covering the move to. Alrighty, so for the move to, we're going to keep this really simple, and we're just going to use a timeline. So the first thing that we want to do is we only want to be able to move one object at a time, so it doesn't confuse the script and get all confusing. So we're going to disable the input to this puzzle once it's been clicked. So once movement starts, we want to get our player controller, and we're going to disable click events. Set enable click events. We'll set that to false. This will just make it so you can't click, you know, multiple tiles in a row, multiple meshes in a row. Just, you know, flow control. So the next thing we're going to need is a reference to our clicked mesh, as we have here. We set it there. Convenient. So we'll get our mesh, and we need to tell our script where our starting position is. So we are going to get relative location, and we're going to promote this to a variable. And it's going to be our move to start. All right. Let's tidy up just a little bit. All right, and the reason we're doing this is, if anyone has ever worked on timelines, you know, if you don't have a set position for a start location, you're going to get all kinds of crazy acceleration and nothing's going to work as you intended. So it's best to have set locations that you're starting from and moving to. All right, so from there we can go and get our timeline. Add timeline. And we're always going to be playing this from the start, so we'll just use play from start. And for our actual timeline data, we just need a simple flow track. We'll go from 0 to 1 over X amount of time. So 0, 0, time 0, value 0, and in, let's say, half a second, we'll move to a value of 1. From there, we will just, we'll say use last keyframe. That will shorten it and end our, it'll end our track here at our last keyframe, basically. Super simple. Let's go back to our event graph. Our new track, that's going to be the alpha that we just set up there in the timeline. That's this. Alright, and so now we're going to lerp some vectors. That's how we're going to be setting our position. So lerp vector. And we're going to be setting the relative location of our clicked tile, clicked mesh. So we need to get a reference to that, and we will say set relative location. Set relative location. And that's going to be on update. And from there, we just need to plug in our alpha, and we need to give it a start and end location. So we know our start location is the move2 start, and our end location is going to be our move2 target. So we will get our move2 target, get relative location, and we know this isn't going to be moving, so this is fine. Clean things up a bit. Alright, so that should all work now, but we also need to remember that we need to re-enable our input. Since we disabled it here, disabled our click events, we need to re-enable click events once this movement is done. So we're just going to copy the same thing, bring it down here, on finished, enable click events, and we'll set that to true. So now when we hit compile, we'll hit play. If we click on a tile, it should move them. Yep. As you can see, if I click one that's diagonally opposed, it doesn't move it. But if I click one that's directly next to an empty position, it does move. Alright, so that is our movement. Alright, so for the last section, all we need to do is we need to check if our puzzle is solved. For that, we're going to create another function, and we'll just say is solved. Let's add a question mark there so we can make sure it's a question. So all we need to do for this is we need to check to see if the spaces list match up with our meshes list. So we will get our meshes, and we need to run a for each loop on all of them, or for each loop with break, so we can iterate through them and check each specific one to make sure it's in the right position. Alright, so the way we're going to do this is we're just going to check if it's overlapping the corresponding index. They all should be in order from the way that we did the spawn. We did the spawn puzzle here. So, like, since we add a collision box on iteration, let's say 1, that'll be set to index 1. And we're doing the same thing here for our meshes. So they all should be in order with where they should be correct. So we'll go into our isSolved function here, and let's start from the end first. We need to tell it if it's solved. So we'll make a return node, and we're just going to output. The only output we care about is it solved? So we'll create an output and call solved, and we'll make that a boolean, and we'll make it a single value. So this is all we care about, is the puzzle solved? So now we need some kind of script to tell us if it is solved, indeed. So we're going to check if our array element is overlapping the correct space. So we'll say is overlapping component, and the other component will be the space. So we need to get a space list array, and we need to get a value, get a copy, and we want a matching index. So there we go. So when we check index 1 of the meshes, it should overlap index 1 of the spaces list. And we'll just add a branch. Alright. So now it just, we know if it's overlapping, then we're good. And it should be good. If we're not, then there's a problem. So by default, we want our solved variable. Well, we need to create the variable. So we'll promote this to a local variable. We'll just call it solved. And I can't because it's already, yeah. Call it solve. So we need to set that variable. So we'll take that, bring it up here, and say set. By default, we want that to be true. And we're only going to set it to false if we fail at some point. So if index 1 is overlapping index 1 of the spaces, then it's true. We're good to go. We'll iterate through the next one, and we'll go through the list. And if it's not true, then we'll just say it's something wrong. There's no need to go through the rest, so we will bring it back and break out of the loop. And I'll just drag that over the top. Okay, so if it indeed iterates through every single one of these meshes and they're all in the right place, then our solve variable should still be true. And so we can just output that it is true. And it's that simple. So I compile, go back to our event graph, and let's just add this in. It is solved. We'll add that right after we re-enable input. And we'll just, for now, we'll print it to the screen. Print string. All right. And at this point, this is where you'd add, some kind of widget interaction or something just to tell the player that they solved it. Since this is not shuffled, as soon as we hit play, it should say that it's solved. And it does not. Oh yeah, all right, there we go. Now it's true. So this mesh is not in the right place, so it said false. We move back. Now it says true. It is solved. That's basically it. Hit stop, we can shuffle it, hit play. As you can see, none of them are in the right place. So if we hit that, it'll just say false, false, and you can sit there and play with this all day to figure it out. But yeah, that's the basics of creating a slide puzzle. It's really not that difficult once you start to understand it and break it down into smaller bits. Just to go over it quickly again, we create the bindings, then we call the event once it's clicked. We reset the binding, we get the neighbors, we figure out which one of the neighbors to move to. If it's valid, we move to there. And then we use our move to function to actually do the movement to move our mesh. And once that's done, we just say, is it solved? And if it's solved, do something. Yeah, that's basically it. One last little thing, I forgot to make our texture public. Hit compile. So now we can set our texture here. We can set it to whatever we like. We can always create a duplicate. And let's say, we'll just make it this little red guy. Why not? And you can, on each instance, you can change whatever you like for the parameters. So I can make this one 500. And yeah, it's pretty cool, pretty simple. I hope this helped you out. Good luck. Thanks. Bye.